In today's video, we're going to be looking at the strength of a line of best fit from statistics and by variate categorical data, meaning that we're going to be comparing two sets of data points, and you're going to see scatter plots, and we're going to interpret and the type of graph it is and interpret the line of best fit. So in the first example, it says a study was done to see the relationships between the height of adult men and their weight. A sample of 100 men between the ages of 20 and 60 had their height and weight measures with their results shown in the scatter plot below. So the slope of the best fit line shown is 3.8. Give an interpretation of what this means in context of the problem. So remember slope, rate, how we figure that out when we graph it is rise over run. So and looks like in this case, it's a positive 3.8. So what's increasing 3.8? So remember, slope is rise over run. So that means it's going up and over, up 3.8 over 1. So that means as the weight of the adult males increases 3.8 pounds, the height increases by 1 inch, since my x value is the height of adult males in inches. All right. Part B, it says, how would you rate the strength of this linear fit of this data? Circle, okay? So now we look at all these dots here. These dots are pretty spread apart, but they're not like, you could still tell the trend of the graph. You could still tell the dots are going up. So I wouldn't say it's completely weak, but I would say it's moderate because you can predict the trend of the graph and you know it's going in a positive direction. Now, if they were really, really close to the line, it would be super strong. The closer it is to the line of best fit, it's going to be the stronger the association is going to be. So we're going to say moderate. So rank these scales as shown as none, weak, moderate, or strong. There will be one of each. Okay, so like I said before, the strongest correlation is going to have the dots closest to the line. So if we look at these, we see which one's the strongest. I would say B is definitely the strongest. The next strongest one would be D. The next strongest, which would be, I guess, weak here. And this one, you can't even tell what those dots are doing. So that would say no association. Same goes with this. As you're looking at the dots, they are decreasing. You can tell the trend. So we know it's a negative association, so we can eliminate these two. And I would say it's about a moderate. It's not really close to, not like this graph right here where it's all close to the line. Okay, they're kind of scattered, so I would say moderate negative association. In this example, it says Kirk decided to do his science fair project on the association between the length of a person's foot and how well they do on a 50-question math quiz. He measured the length of the right foot of 100 subjects in centimeters and then has them take a quiz. So we look at this association. It's really tough to tell this association because the points are really scattered. This is, what would the linear model equation predict for the number of questions answered if a person had a right foot that is 25 centimeters in length? So if somebody has 25 centimeters in length, foot, is that the x value or the y value? It's the x value. So what we would do is we would plug this into our equation for x. So we have y equals 45 times 25 plus 20. And I do that in my calculator. 3125. So about 31 corrections correct. How would you rank this? I would say it's weak. It's tough to tell. Like, those dots are really not close to the line. If that line wasn't there, it would be hard to tell. It's positive, negative. Part C, if Kirk used his model to predict the number of questions a person would get correct on his quiz based on the right foot length, how reliable would this prediction be? I would say it's not very reliable. Since the data points have a weak association. Why do you think there's a gap between 0 and 10 centimeters in foot length? Because not many people have that size foot. Think about it. Between 0 and 10 centimeters, not many people have that size foot. So a lot of today's lesson is basically reading a graph and interpreting it and seeing the association, the strength level of the association based on the data points, and interpreting different parts of it, like slope, or whether you plug in a data point, what's going to happen. So that's what a lot of this lesson, or a lot of this unit coming up is pretty much interpreting these data points. All right. So thank you for watching today's video. If you have questions in class, let me know.